Okay, this is section 5.1, which is called Identifying Linear Functions. I'm going to try and keep this video pretty short and sweet. For something to be a linear function, it has to be a function. You can't be a linear function if you're not a function. And then you also just, linear means a line. So when you're looking at graphs of these, if something looks like this, a parabola, well, that's not a line, so that's not a function. Really, the graph ones should be super easy, because if it's not a line, you know right away it's not a linear function. The only line that can be tricky is if you have a vertical line. A vertical line is also not a linear function. And the reason that the vertical line isn't a linear function is because, do you remember that vertical line test for functions? Well, this doesn't pass that vertical line test, so this can't be a function. Any other line that you see on a graph is going to be a linear function. The other way that they talk about in the section determining if something's a linear function is if you have this XY table and you see in the X column, so I'll go over here, you see there's this constant rate of change. So you have a 2, 4, 6, 8. If these X's are increasing or decreasing by a steady number, if there's a constant rate of change, so in this case you're adding +2, then you look over at your Y table. And if your Y table also has some constant rate of change, it doesn't have to also be +2. In fact, this table could do 9, 6, 3, 0. But since you see that there's this steady -3 happening, that means that this is going to be a linear function. And it's because this has a constant rate of change, so does this. If this has a constant rate of change and this did not, say for example it was multiplying. So you look over here and it's going 2, 4, 8, 16. Well, it has to be a rate of change that's adding or subtracting, since subtracting is just adding negatives. So this would be not a linear function. Okay, you also learned something really important in this section called the standard form of a linear function. So standard form. The standard form of a linear function is ax plus by equals c. This a and b and c, these are just numbers. So I sometimes tell students to think about the standard form as being like x plus y equals a number. Because this is just some number, this is some number, this is some number. What's important in standard form is that you have x plus y on this side, and they're equaling number. When you are determining if something is a line, it has to be able to be written in this standard form. So if, for example, if you see you know something is not standard form, if you see exponents. If your equation says x squared plus y equals 5, this is not standard form because it has an exponent. If there's any exponent, it's not standard form. It has to just be that x plus y equals number. Or not only is it not standard form, it's not a linear equation. So actually, I should even say not linear equation. So no exponents in linear equations. The other thing you can't have in linear equations is you can't have the x and y being multiplied or divided by each other. So if you had something like x divided by y equals 5, this x and y can't be multiplied or divided by each other. So these are both not linear equations. The other thing that isn't allowed to happen in a linear equation, you can't have the x or the y in the denominator. So if you had something like 5 over x plus y equals 7, you're not allowed to have any x's or y's in the denominator. So you know something is not a linear equation. I'll go ahead and erase that. So it's not a linear equation if it has exponents, if you have the x and y being multiplied or divided by each other, or if you have them in the denominators. So these things are key indicators that it's not a linear equation. Just a couple quick examples of what are linear equations. So these are linear equations. That would be if you had 3x plus 2y equals 8. That's a linear equation. You can see that's not only is that a linear equation, it's in that nice standard form where you have ax plus by equals c. They don't have to be in standard form to be a linear equation. They just have to be able to be rewritten in this standard form. So if you have like y equals 3x plus 9, this is a linear equation. And you can tell it's a linear equation because there's no exponents. The x and the y, they're separate, so they're not being like multiplied or divided by each other. And there's no x's or y's in the denominator. So this is good. Another one that would be good, you can actually have just something like y equals 4. That is a linear equation. This is a linear equation because y equals 4 is just a horizontal line that goes through the 4. The only thing I would say here too is be careful. If you had x equals something, like x equals 2, that's this vertical line. So even though, yes, that's a linear equation, this is not a linear function. And again, it's not a linear function because it's this special case where you have that vertical line that, yes, it's a line, but it's not a function. And this is the only example that you would have that is a line, but isn't a function. This one is okay, because this not only is a line, it also passes that vertical line test. And that is it for section 5.1.